Hola clase. Today we are learning the rules of exponents, 7 rules, and for each one I will give you an example. So all of it comes to the idea of what is an exponent. So remember, I read them as a to the power of n, and that's nothing more than a times as many times as n times. I call a the base, the number that's in the bottom, and n is the power or exponent. First rule of exponents. A to the power of n times n to the power of m, two different numbers, is the same as a to the power of n plus m. I add the exponents. With an example, let's imagine we've got a square, a to the power of 2, times a cube, a to the power of 3. If I begin expanding this, I would have a times a from this square here, times a times a times a, which are the 3 ones from the cube there. If I count how many, that is the same as a to the power of 5, which is the same as 2 plus 3. That proves my rule works. The second one, a to the power of n over a to the power of m. That is the same as a to the power of n minus m. I subtract the exponents. If we see an example, let's imagine we've got a to the power of 4 over a to the power of 2, a square. I do the same, I expand each one of these, a to the power of 4, a 4 times itself, a square, a 4 times itself, and I see I can cancel a over a 2 times. What I'm left, it's a to the power of 2, a square, which is a subtraction. Next one, a to the power of n, all of that to the power of m. What I do is I multiply the exponents, a to the power of n times m. Let's see another example. Let's imagine we've got a square, all of that cubed. If I expand, it's the same as having a square times itself 3 times. That's what an exponent tells me. And by rules of exponents number 1, that is a to the power of 6. The following rule, a to the power of minus n, a to the power of a negative number, is the same as 1 over a to the power of n. Let's make an example that will make things easier to see. Let's imagine we've got a to the power of 2, a square, over a to the power of 4. If I expand this, a square is a times a to the power of 4, it's a times itself 4 times, and then in my mind I can simplify a over a 2 times, and I'm left with an a square in that denominator. And the numerator, what I've got is that 1 multiplying that I never write, but I need 2 now. Now, if I use the rule of exponents that told me to subtract the exponents, that same division, it's a to the power of 2 minus 4, 2 minus 4 being minus 2. These two things are the same, so the results are the same. A to the power of minus 2 is the same as 1 over a to the power of 2, or a square. Next one, if what I've got is a fraction, a to the power of 1 over n is the nth root of a. Remember that, for example, if we write a to the power of 1/2, that could be the square root of a. If we would have a to the power of 1/3, that could be the 3rd root or the cubic root of a. The last two rules, a to the power of 1, a times itself 1 time is the same as a, and a to the power of 0, it's always 1. As far as a is not 0, but we're not going to go there. I'm going to give you an example so you will see it easier. Let's imagine that we've got a to the power of n over a to the power of n. Well, they will be the same number, so that division is 1. And at the same time, if I've got a to the power of n over a to the power of n and I apply rules of exponents, n minus n, that could give me 0, a to the power of 0. Again, these two things have to be the same, so a to the power of 0 is 1. These are the rules of exponents, and then with these I've got a couple of side notes. Things that depend on the number of the base. For example, 0 to the power of n, you think of that, it's 0 times 0 times 0 n times. That's always going to be 0. Again, as far as n it's not 0, that's an indetermination and we're not going there. 1 to the power of n, well, 1 times 1 times 1 as many times as I want, that it's always 1. And remember, these rules are for the exponents. I need to have the same base. The base don't mix. So if I could have something like a to the power of n times b to the power of n, I cannot use the rule of exponent and add the bases. That's not the same, only exponents. Here you have it, 7 rules like the 7 little dwarfs. Now it's your turn to go and practice. Thanks for watching.